Hi, my peoples. So Unit 2 for chemistry is actually part 1 of matter. And so our first 3 units or so, we're really talking about basics before we get to true chemical theories and all that kind of stuff. So some of this is going to be review, and so just kind of bear with me as we go through it and just make sure you know it. So we start off Unit 2 with the separation techniques. And I would like to say right here from the get-go that please do not feel sad about your own artistic abilities compared to my own, because obviously they're very high. So I attempted to draw some of the equipment that we'll see in these separation techniques, but yikes. All right, so here we go. Separation techniques are used to separate physical mixtures. Physical mixture means that they are not chemically combined, that the parts that are put into the mixture can retain their own physical properties. So if we do this in class, and I'll try and figure out how to do it if you're doing this at home, actually they'll probably be on the PowerPoint somewhere if I can get it worked out. We'll show you some little YouTube clips for these. And so if you don't see any links to click on, if you're looking at the PowerPoint, just Google or search some of these on YouTube, and it can show you kind of what I'm talking about. I think most of them, though, are pretty self-explanatory. Okay, so first off, magnets. Magnets are used to separate metallic substances. So if you have something like a mixture of sand and iron filings, then you could use a magnet to pull the iron out away from the sand. You probably did this in 5th grade with Mrs. Collins if you were at our school, because every year she borrows magnets and iron filings from me to do this. So you may remember that. A second thing that is a separation technique is the use of a separatory funnel. And it is a kind of a glass, kind of a bulb, like I attempted to draw there on your screen, as you see. And it has an opening at the top, and then at the bottom it has a valve. And so you have 2 liquids. So for instance, if you had oil and water that are mixed together, so let me try and write stuff on here. So if you have oil and water, those 2 won't mix, or they will separate themselves, and the oil will float on top of the water. And if you let them set long enough, then you will get a very distinct level or layer of oil above the water. And then you can use the valve at the bottom to open up and let the water drain out into a beaker that would be sitting down here below to catch that. And so and that way you can separate the 2. It's, you don't get them completely separated because it's hard to get it just right, but it is an easy way to get the bottom liquid out if you needed it. Okay, so now here, I know, fantastic drawing. The third separation technique is distillation. And this separates 2 soluble liquids. This means they will dissolve in each other, or a liquid from a solid. So for example, if you have something like alcohol, oh, that's hard to write, alcohol and water mixed together, then you could separate those. And so if you have them, they will generally have 2 different boiling points. Alcohol will boil much quicker than water. And so if that's what's over here in this first little container, that first little flask, you have your mixture. When you heat it, the alcohol will boil much quicker, and it will travel in vapor form up into this little tube and down into a condenser. A condenser is a tube within a tube, and the alcohol will go into the inner tube. The outside tube is going to be connected to water, and so water, like from a sink, is flowing through the outer tube. It's cold water, and so the cold water will cause the gas form of the alcohol, in this case, to condense, and so that's why it's called a condenser. And then as it condenses, that pure liquid, so in our case the alcohol, is what will then drain down and drip down into this other little flask down at the end. Notice it's always at a tilt so that you have gravity helping it roll on down. But this is distillation. It's a very good separation technique because they're usually, very distinctive boiling points between the two liquids. If you have a solid in there, you can do the same thing. You can just boil the liquid, and then the solids will just end up over in the original container. This is where we get, if you've heard about, people like running moonshine and all that kind of stuff, or if you watch the TV show MASH and they talk about the still, this is where that comes from, still from distillation. Okay, now decanting. Decanting is kind of a fancy word for pouring. And so this is where you have insoluble solids and a liquid. So for example, if you had something like sand in water, you can separate the two of them. And so if you'll let let it set, and the sand will settle down to the bottom, and then you can, not very accurately, but you can pour off the water from the sand. And so it's not, you can't, again, completely separate it. The plus to decanting is that it's very fast. You don't have to set up a whole bunch of equipment. It's fast. The bad part is it's inaccurate. Yeeks. Okay, now filtration. So this first fantastic drawing is filtration. And so with filtration, you're basically doing the same thing that you did with decanting, but it is a slow process. But on the upside, it is pretty accurate. You pretty much separate it completely. Okay, so you have a filter, obviously, and you put it down inside a funnel. I don't know if you can tell, that's what I drew, but I did. You put it down inside your funnel, and then you pour your substance down through it. The solids will remain in the filter paper. They will be too big to go through the filter paper, whereas the liquid will be able to drain through down into that little beaker below. It's a slower process. You have to wait for it to drip. You have to, go through all of this stuff, but it does more accurately separate. Evaporation is when you want to separate a dissolved solid from a liquid, and you don't really want to keep the liquid. So the liquid's not really a big deal. You just let it evaporate. So if you had something like salt in water, you could boil that. You would lose the water, and then the salt would just remain there in the dish. This little dish is called an evaporating dish. It's just a little porcelain bowl looking type thing. Okay, sifting. This, again, not super high tech. Sifting is when you have solids that have different sizes. And so your sifter is basically like a screen or something that has holes in it. Smaller particles will fall through and be separated from the bigger particles that can't get through the screen. Manual separation, kind of like it sounds. I drew a pair of fancy tweezers there, but you could use your hand or something to pick up different pieces based on different size, different shape, different color. So like if you have a handful of coins, you would manually separate that into the dimes, the pennies, the nickels, the quarters, whatever. Okay, centrifuging. So this is a little bit more complex. This is where you separate small insoluble solids from liquids. Very often you will see, if you've ever had blood drawn, in their lab, you might see a little machine, a little centrifuge. It basically spins test tubes at high speeds. And so if you have a blood sample in this test tube, it will spin it, and the heavier particles will go to the bottom, the cells, the white blood cells, red blood cells, and then the plasma and the water, which is the majority of it, will be on the top. So if they're trying to do different studies of that blood, then they can separate out the parts. The last one is chromatography. Chromatography separates solids in a liquid by mass, and they will do this they can do this like when they do urine tests for different drugs, different substances, different inks. They can do this with blood or DNA, even a form of it. And so what you do with this is you have a piece of filter paper. So this little kind of square is the piece of filter paper, and you put your different samples. So these black dots down at the bottom are like ink dots. So if you're trying to figure out which ink or which pen was used on a certain piece of paper, then you could compare it to this chromatography. And ink, for example, will separate out into different color bands. So black ink is made up of a bunch of different colors. And so from that, you could be able to compare it to your original. It's one of the ways they do using a similar technique, but kind of different substances to test like DNA, paternity type things. Okay, now these last 3 pages are a cover for something that we're doing in class, and just the different definitions of matter, some of the different characteristics of matter. I'm not going to run through them. They're very self-explanatory. If you had that worksheet that we did in class that's going to go into your notebooks, and you need this information, here you go. Same thing for this. This is still on that little chart that we're filling out for our notes. So elements, compounds, again, things you'd need to know the basics here. Read through this. Again, I'm not going to go through it. And then finally, mixtures. All right. So that's Unit 2, super short as far as the information goes. I hope you got it. Ask me always if you have questions.